let's try to solve this problem here. In the figure above, a small cut of mass 4 kg. So this cut here has a mass of 4 kg. Let's label it here. Moves on the frictionless track. Okay, if you see that this track is frictionless, then you know that it will fulfill the requirement for it to be an isolated system. Then you can apply the principle of conservation of energy. Okay, if it's a rough surface for the track, then the mechanical energy will not be conserved. Okay, so it has to be a frictionless track with a speed of 10 meters per second along AB. So the journey from A to B will take we have a speed of 10 meters per second. Then the cart will go down to C, then it climbs up to D and E. Okay, so now they ask what is the change in potential energy of the cart between point B and D. Okay, so I believe this potential energy here, it's the gravitational potential energy, and you're asked to find the change in this gravitational potential energy. Okay, so change, you represent it with this delta. So this is potential energy. To be more specific, is gravitational potential energy. And because its change is always final minus initial. Okay, our final destination over here is D. Our initial point is B because we travel from B to D, right? So let's write it down. B will be your initial position, whereas D will be your final position. Okay, because of that, you can change it to become UGD minus UGB. Okay, so how do you find the gravitational potential energy? It's just mgh. So this one is mghd, whereas this one is mghb. Okay, now you know that mg, they are the same unknown. You can factorize it. So now you're left with finding the difference in height between D and B. Okay, so now this is a point where it gets interesting. To determine a height, right, you have to have a place in which you start to measure the height. And we call that place where h is equal to 0 as the reference height. Okay, the thing with reference height is actually up to us to decide where we want to set the reference height to be. Okay, let's say you can set point C, the lowest point here, you can see as a reference height. If you set here as the reference height, then now point D over here, the height will be 5 plus 2. In that case, your height, okay, let's substitute, the mass is 4 kg, your G is 9.81, but your height of D will be 5 plus 2, which is 7, so you can write it down as 7. And your height of B is over here. The height, if measured from C, it's 5 meter, so you can minus 5 meter. Okay, if you choose to do it like this, you get an answer of 78.48 joule. Okay, but if today you say let's not put point C as our reference height. Okay, let's not put here as our reference height. Instead, let's choose the point where all the measurements are made from. We want to put point AB here as our reference height. If you put point B here as our reference height, if you do your substitution, it will be 4 times 9.81. But if you do your HD, point D is 2 meters above the reference height. 2 meters above the reference height means by your height is 2 meters, but it's positive. Okay, actually you can put all these values here to be positive. There's no problem with it. Minus positive 5, that's fine as well. Okay, for point B is at the same height as the reference height. So because point B is at the same height as reference height, we know that reference height is the height in which the h is equal to 0. So we can minus it with 0. Okay, so if you do your substitution here, you see that this part here is equals to 2. And if you check it for this one, you'll see that it's also equals to 2. Okay, so what am I trying to say here is no matter where you set as the reference height, if you do your substitution, your change in your gravitational potential energy should be the same. Okay, even though mghd will be a different value, mghb will be a different value if you pick different point as reference height, but the change of gravitational potential energy should still be the same. Okay, so if you calculate here, you still get 78.48 joule. Again, what's the key message here? No matter where you pick your reference height, you will still get the same answer for your change of gravitational potential energy. Okay, next, calculate the speed of the car at point C. So they ask for the speed over here. You know that throughout the journey over here, you should have your mechanical energy being conserved. So the mechanical energy at point AB should be the same as the mechanical energy at point C. Because of that, you can equate the two mechanical energy, the mechanical energy at these 2 points. So you can say that E at point A is equals to E at point C. Therefore, you can expand the mechanical energy to become the sum of kinetic energy and the sum of gravitational potential energy. Because there's no spring, so you don't need to talk about elastic potential energy here. Okay, you can expand it to become Kc plus UgC, kinetic energy plus gravitational potential energy. Expand it further, this will be half mVA square plus mgHA is equals to half mvB square plus mgH. Okay, the nice thing that we can see here is all the terms here, they all have m inside it. So what we can do is we can cross out the m over here because they all share the same mass. Okay, now you can proceed to your substitution. Okay, before we do our substitution, right, you know that later you need to substitute in height as well. So we are going to set the reference height as usual. So let's pick point C here as our reference height here. Okay, so now we know where is the reference height, we can do our substitution. So half VA, VA means by the speed over here, we know it's 10 meters per second. So 10 plus G height of A. Height of A, if measured from point C upwards, it's 5 meters upwards. So this one will be positive 5. Okay, is equals to half VB. Why am I writing VB? I'm comparing with C, right? Haha, it's my mistake. Okay, I'm comparing it with mechanical energy at C because you're interested in value at C. Okay, so VC is what we want to find. So let's write it down as VC square plus 9.81. What's the height of C? We put our reference height as C. So if point C is at the reference height, so the height over here should be equals to 0. So your height over here is equals to 0. So if you do your substitution, you are left with only one unknown, which is VC. So if you calculate it, you get VC to be equals to 14.07 meter per second. Okay, so a very simple example to illustrate how you compare between the mechanical energy at 2 points. You usually take one point to be a point where you have all the values. You have your kinetic energy, you have your potential energy. But another point will contain the unknown where you want to determine. So in this case, you want to determine the speed, right? So the speed is at point C, so that's the unknown. So we compare it with mechanical energy at point C. Okay, one with all the things that we know, one with something that we don't know that we wish to determine. Okay, so that's how we apply the principle of conservation of mechanical energy in this particular question. Thank you very much.